on the JSW. My request will be, because the time is running short, this session is already late by around 40 minutes. If most of the panelists can limit their presentation to the R&D effort they are making in this direction instead of making a corporate presentation or other things, and try to limit it within 8 to 10 minutes if possible. Thank you.
Thank you, sir. Thank you, Chairman. Ladies and gentlemen, I will be presenting something on technologies for sustainable recycling of steel plant waste. Since morning, we have been hearing about the production going up to 300 million ton, and the technology is needs to adopted, or innovation being to be done on the raw material sides and on the products. So these two are two sides of an integrated steel plant has been looked upon. But there is a third side left. When we increase this, there is a huge amount of waste also being generated. How you are going to take care of them? You are increasing the volume of the steel, 1.5 times of the volume equal to the steel will be various kinds of waste which we will be generating. So I'll be focusing on certain things about how technologies are going to come for large integrated steel plants, what technologies are presently being utilized, and what is the trend in which the waste would be handled for the large integrated steel plants in future. One important point is that the integrated waste management system has to be adopted. Just to start with the very basic thing, for every ton of steel produced, we have close to 3.82 tons of raw materials. But important point is there is almost 700 kgs of waste being generated. This needs to be handled, and in volume it will be 1.5 times of the steel. So for every ton of steel, at 300 million ton, maybe 450 million tons of solid waste will be there, which equivalent volume would be there to be handled. How we are going to take care of those things? If we divide the whole waste into 4 basic categories, we will see that it's basically iron making slag, steel making slag, sludge, and dust, which comes from various parts of the steel plant. And utilization rates are very low. It depends upon plant to plant. Important point to be seen is even those utilizations which are on the higher side comes from a single point saying that the landfilling is also being taken as an application. Now, when I talk about sustainable use of those materials, landfilling doesn't come into this picture. We would like to convert them into products. That's what I was going to show it to you. But when I say sustainability or sustainable handling of these materials, there are 2 important terms which comes into picture. First is we shouldn't treat it as waste. It should be called as byproducts. Second, we shouldn't look into the disposal, economics of disposal. Rather, we'll look into business opportunities, how we are going to convert this into business opportunities. This is the only way you can call or you can see that how sustainable solutions for these waste could be driven up. I will divide this into 2 parts. First is the slag, second is the dust and sludge. If I put slags together, there are 3 parts where basically slags are generated, 3 locations where slags are generated. And they come from different processes. And that makes the problem more complex. You have to develop solutions for different types of materials which have different compositions, different sizes, different kinds of reactivities. When we talk about iron making slags itself, in most of these steel plants, what do right now is they granulate 90 to 95%, and then rest 5% is going to the dry pit. But again, this is being dumped, most of these steel plants. So there is a solution needs to be found out for this. When I talk about even granulated slag, which is going for steel making, if we triple our capacities, do you think the cement plant, cement capacity is also going to triple at the same time? So there is a situation going to come where you will going to start accumulating this slag also. We face this problem at JSW, especially in the southern India. So we need to find out alternative applications for granulated iron making slag as well as for dry pit slag. One innovative thing what we have done there is we converted the blast furnace slag into a sand. Sand is a scarcity. There was a huge market. It clearly matched the requirement. Of course, we need to develop certain technology which is been patented by us, where we alter the granulation technology, shape it, screen it, and convert into slag, which is 100% replacement to river sand. Right now at JSW, 30% of its slag is being sold as sand, and rest 70% to the cement. So we need to find out some solutions like this. When I come to the dry pit slag, the integrated steel plant people must be knowing that most of the modern blast furnaces have a dry pits of very smaller capacity. You send your slag there and simply quench it with water. It gets bolted. And finally, it doesn't remain as it should be in normal air cooled. And that is one of the reasons why it was not getting utilized, and most of the people were dumping it. 2 solutions what we find out at our place was we send it to crusher and screen and a pug mill and try to mix it with steel making aggregate and try to form of a proper CBR ratio for the lower ends of the roads. NH63 in Hospital Bellary Road is a very excellent example where this has been getting utilized. Second part is, of course, this continues till the road is there. Once the road construction stops, we move to the second route where we crush them, screen them, size them, and again convert them into slag. Sand, because these are very porous, light, and can generate a lot of revenue. So this is one way we can take care of the whole of the iron making slag for large integrated steel plants. Coming to steel making slags, we have different types. Similarly, you have two different types of technologies which are available in the present scenario. You granulate EF slags, BOF slag itself. BOF slag, you require aging to be done. In granulation, normally we send it for cement, fine aggregate, some filter media, etc. When we talk about granulation, there is certain things which we need to understand. 100% of the slag cannot be granulated. Only the top portion of the slag can be granulated. So when there are two basic technologies which are available in the world, and I don't see any new technology coming up at this moment in sight where which matches to these two, BSSF and EcoMaster. Maximum 50% can be granulated. So 50% still has to go to air cooling. Viscose slag cannot be used, limited applications and high cost. But I would still suggest that in future for large integrated steel plant to increase your applications, this is one of the technologies to be adopted for handling your slags. The rest of the slag, which goes for open air cooling, where we dump it into pits and try to use it for various applications. We know there are issues of instability. If you use it directly, it cracks. So you require to do certain amount of aging. Some of the large integrated steel plants have already adopted certain aging techniques. But most important part to be understood here is whenever we talk about aging, so much has been published on aging. The aging is applicable only to the 40% of your total slag generated, which is of a larger size. Rest of the finer size, which is minus 10 mm, is still dumped all over the world. So we need to find out applications for rest 60%. Now coming to this 40% where aging is required, it involves cost. Maybe that is one of the reasons why most of the steel plant didn't adopt it. So you need to find out easy solutions for aging of this coarse part, and you need to find out some solution where this can be divided and can be utilized. I will suggest few solutions which we devised at our end. First, starting with the coarse part where aging is required, we know that there was a natural aging technique, then dry and wet aging came up. There has been a lot of literature being published on open steam aging, pressurized steam aging, steam box. Many steel plants have adopted some of them. These are one of the viable solutions for that 40% of your slag generated. But in a long run, when we are talking about 300 million ton, where individual steel plants would be of say 10 million ton or 20 million tons of capacities, these kinds of aging techniques may not be viable. For those, these are some of the technologies which people are being started working on along with us at JSW. This is a chemical stabilization of the slag. So we don't do any post-aging, but we do pre-aging. We convert this slag in the molten state itself in such a way that you don't have to do aging and becomes a stable aggregate. This is one part of the application. There is another part of application which is coming up in future. Maybe the new greenfield projects will have to adopt certain thing, which is converting the slag directly into clinker. Cement plants are one of the biggest scavengers where they can consume a lot of waste from all over different industries, and steel slag is no exception. If you can convert or modify the steel slag before you dump it through certain techniques, just like what you do in your LHF, after tapping from the converter, you treat your steel to make meat to your customers. Similarly, you have to adopt another LHF on the slag side where you have to treat them with additions and other things, and then you make a slag which is similar to the cement requirement. This could be one of the two solutions which we see coming up for future large integrated steel plants. The rest of the part, you need to convert them again into sand. Sand is one kind of area where I see that there is a lot of scope, lot of demand going to come up because of lot of environmental restrictions in river sand. It's possible to convert your fine part of your steel slag into sand. We have done this, we have experimented it, and this is one of the plant which is coming up at JSW, where now we have been able to take care of all of the steel slag very soon. We will be able to convert into a very profitable business model. Some of the future applications, in addition to this, what we see is water treatment, ground stabilization. These are the certain applications which have been done on very small scale at different parts of the world, but we see that there's a lot of scope in India. Hydrated slag boards, we have a very large coastal area where you can use it in the form of wave breakers, ferroforms, artificial stones, algae constructions. The scope lies, they all had been found that steel slags found to be very good for these applications. Another important part is the self-bound roads. We have built one such road where you don't require any binder. You just mix blast furnace slag and steel slag and an activator, and it forms a very good road with a reduced thickness. Of course, some standards needs to be amended for this, but this is also one of the future solution when we go for such a huge quantities. The rest of the LHF or the secondary steel making slag, it can go to cement making or synthetic slag, and the silicon kiln has to go to special. But here, the steel plants have to separate both these slags separately. That's one of the requirement for applications. Coming to the last part, the dust and sludge. Dust and sludge is generated at various parts of integrated steel plant. This is one of the big challenge what we have. Different dusts have different composition, different sizes, different moisture content, etc. Right now, what most of the people have adopted is a secondary beneficiation where they use cyclones, dual extraction, and again recycle back into pellet or sinter. The another way is briquette them and use it in steel making, iron making. You can micro pellet them and use it in sinter making. These solutions are well proven, but good for small steel plants. But when you talk about 15 million, 20 million tons integrated steel plants, they may not be sufficient. There are certain concepts which has come up, which is called integrated waste management system. There are a lot of technologies which has been proposed recently. What they do is they bring all these wastes to a single place, and a single process concept has to be adopted for such a big steel plant. Because when you are a 20 million ton steel plant, you will be generating close to 0.5 million tons of dust and sludge, and it's huge. The one way the people have been doing it is you bring them to a dryer, a briquetting press, put into DRI unit through a small mini blast furnace, and you convert everything into slag and metal. All your waste is converted into one form of slag, and then the application becomes easier. Another technology which has been recently been published in some of the literature is through mini electric arc furnace or rotary hearth furnace, etc. But here still a question mark lies that you are converting all waste into a steel slag, for which still the applications are difficult. So rather I would say what we see or we envisage after a lot of work, we find that this through a sinter plant and a mini blast furnace finds to be a most easy solution, especially for a large integrated steel plants. We have been working on this concept and these trials, which prove that how can convert all dust and sludge and recover most of the metal, and still you have a waste which can be utilized, sold, and make profit out of. Finally, to conclude, Indian steel plants has to recognize that to remain competitive, they have to take a fresh look into this. The zero waste concept has to come. Nothing has to go out of the steel plant. Everything is a byproduct, and everything has a business opportunity. And proper management and effective utilization is the one which has to drive to the future, especially when we are talking about such a huge capacities. Thank you very much.